Happy Tuesday, everyone. I am on a little bit of a run here where you're not going to see me as much over the next couple of weeks. Unfortunately, got a lot going on as far as with golf and an athletics meeting. So, anyways, today is one of those days that you'll be without me. I'm sure that's going to kill you to not have me there. But, anyways, I want to I want to, of course, go over or at least put up the answers for last night's homework. I know that you had a lot of time in class to work through this, so I'm sure there's really no issues. It was pretty easy. It was just a review. So here they are. You had number 8 through 15. So that was I, D, O, G, H, E, J, K. And just as a reminder, if you missed it yesterday, O was supposed to be X 12x cubed. So again, if you were doing this and you didn't hear me say that, and you ran across number 10, that should have been O. So anyways, there's those answers. If you don't understand one, I do have a key that I've left here that's on my desk. Feel free to check it out or put a little mark by it. I will be back tomorrow, and you could ask me then. I'm going to go to the other side. It was on a different worksheet. But anyways, I attached it to yours. So here they were. Number 5 was x squared plus 11x plus 28. Well, I'll let you just read them and check those real quickly. This is numbers 5 through 10. I'll put up number 12 here in just a minute. Again, these are just the answers. I do have the work done on that answer sheet that is on the front desk or on my desk, and it's marked last night's homework. If you want to check it out, again, I'm sure the sub would love for you to see that, and you can see every multiplication that I made, and then, of course, the like terms that I combined. A lot of times, if you miss just a single term, let's say you're doing number 10, and everything looks right except maybe this one, it could be as simple as you made one mistake multiplying. If a couple of them are messed up, a lot of times what we do is we mess up on the variable, and we end up putting a variable in the wrong spot, combining it, and it messes up a couple of the spots. So anyways, there's a couple ways you can miss those. All right. Hopefully you did well with this. Let me scroll down. You've had long enough to look at 5 and 6. So we'll zoom out just a little bit and leave number 12 on there as well. 8x cubed plus 72x squared plus 216 plus 216. Oh, well, sorry, 216x plus 216. Okay, so that was just kind of a review over adding, subtracting, and multiplying. Now, today, and these notes, if they're not at your table now, they'll probably head this way. We're going to start with just the first page today, dealing with GCF, some difference of squares, and some in difference of cubes, and then look at some trinomials. Tomorrow, when I'm here, we'll clean any of these up that you struggle with, and then move along to probably my favorite type of factoring, and then go from there. So anyways, I do want to remind you that when you're factoring, please don't forget that you always have to start with GCF. And it doesn't matter if we're just factoring quadratics or even if we're factoring like today, as you can see, we're factoring bigger than quadratics. See, this has a cubed. These have a bunch of variables. So these are not just quadratics, but you can still pull out a greatest common factor. So in this first problem, and I'm not going to do every one of these. I'll do a handful of each. But on number 1 here, we can pull out, obviously, the number 2, but the variable a squared. So we're going to pull out 2a squared. I don't like that pen being so thick. So let me change that. So 2a squared. And let's see what that leaves me with. So 2a squared out of 12a cubed. 12 divided by 2, of course, is 6. And then a cubed divided by a squared is going to leave me with just 6a. And then positive 10 divided by 2 is positive 5. And the a squareds cancel. Okay? All right, number 2. I'm going to do 2 and 4. I'm going to pull out of 14 and 7 the greatest common factor 7. This one has m to 8. This one has m squared. So m squared is the most I can pull out of both. This has n to the 5th. This has n squared. So n squared is the most I can pull out of both. Well, 14 divided by 2, or 7, is 2. M to the 8th divided by m squared leaves me with m to the 6th. N to the 5th divided by n squared leaves me with n to the 3rd. And that one's done. And then here, negative 7 divided by 7 is negative 1. And the m squareds will cancel. The n squareds will cancel. So simply left with 2m to the 6th n cubed minus 1. All right, scrolling right down below. Now we have 3 terms, 16, 12, and 32. We can take out the number 4. And then x third, x squared, x to the 1st. So x to the 1st is the most we can take of all. Y squared, y cubed, so y. So we can pull out a 4xy. So here we go. 16 divided by 4, 4. X cubed divided by x is x squared. And the y divided by y will cancel. Negative 12 divided by 4, negative 3. X squared divided by x will leave me with x. And y squared divided by y will be a y. And then lastly, 32 divided by 4, positive. Let's see, my brain just went dumb. Positive 8, sorry. The x's, x over x will cancel, but y cubed divided by y is y squared. All right, so GCF, please don't forget that every time you look at a problem, you need to still check to see, is there a greatest common factor? Okay, now moving along. I'm not going to have to spend much time with difference of squares because you've already done this, okay? We've already talked about these perfect squares. 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the first 10 perfect squares. But remember, when we're dealing with difference of squares, here's the rules. They both have to be perfect squares. Something has to multiply by itself to get that value. They have to be perfect squares. Secondly, the sign in the middle has to be minus. Now, if that's the case, remember, this is how we factor. It's going to factor into 2 binomials. Remember, I told you it's the one time a binomial will factor into 2 binomials. And the rule is it's a times a to give me a squared. It's b times b to give me b squared. And then 1 is positive and 1 is negative. So let's look at a handful of these. Let's just go up this right side over here. Again, look at 9. X squared. Is that a perfect square? Well, absolutely. 3x. How about 49y squared? For sure. 7y. So this will definitely factor into 2 binomials, where 1 is 3x, 3x, and 1 is 7y, 7y, and the rule is plus minus. Okay? Now, in the process of us doing this, again, you might come across number 8 and be like, hey, 72 is not a perfect square. 2 is not a perfect square. And you're exactly right. But please don't forget, you're still supposed to check this to see, is there a GCF? And sure enough, we can pull 2 out of both of these terms. Now, if I pull 2 out of 72, that's 36, c to the 4th. And if I pull 2 out of 2, that's a minus 1. So all of a sudden, we pull out this GCF, and now we're left with difference of squares. So sure enough, it will factor into 2 binomials. What will multiply to get 36c to the 4th? 6c squared, and 6c squared. And then what will multiply to get 1? Well, of course, 1 and 1. 1 has to be plus, 1 has to be minus, and now that one is done. Okay, hopefully that's pretty easy. We'll do one more, number 10. Well, I definitely can pull a 10 out, can't I? And I can pull out a w, 10w. So 10 divided by 10 is 1, but w to the 5th divided by w to the 1st is understood to be, well, not understood, it's w to the 4th. And then, of course, negative 10w divided by 10w is negative 1. Sure enough, difference of two perfect squares. So this will factor into two binomials. What multiplies by itself to get w to the 4th? W squared times w squared. Of course, 1 and 1, plus and minus. Done. Now, real quick, don't want to overlook, because we actually got, because this was w to the 4th, and we multiplied w squared times w squared, I want you to notice, let me write all this. None of that can factor, but I want you to notice this one. Because of difference of squares, even though I factored it once, that one can still be factored again. It can be factored into two binomials. And this is where this stuff kind of gets tricky. You kind of always got to be on your toes, making sure that something might be able to factor further, like this one does. Think about it. What multiplies by itself to get w squared? W times w. What multiplies to get 1? Well, 1 and 1. And since that sign is a minus, difference of squares, one of these is plus and one of these are minus. So real quick, let me just remind you guys, well, why couldn't we do that with this one? Well, because, yeah, those are perfect squares, but that is not a minus sign. That's a plus sign. So it's not difference of squares, and therefore I can't factor it any further. So difference of squares is something that we've talked about. We talked about it specifically with quadratics, and now we're adding another step to this, because we're not just dealing with quadratics any longer. We're dealing with bigger stuff, like this quartic one here, or this quintic one here, where we had to factor out a GCF, but then we can factor further from there. Okay, I do want to show you 9. That may be a little tricky. I can definitely pull out a 7. This one has m to the 7th. This one just has m. So I can pull out an m. And even though this one has n cubed, this one just has an n. So I can pull out an n. So here's what I'm left with. 7 divided by 7 is 1. But m to the 7th divided by m is m to the 6th. The n's cancel in that term. Now, negative 28 divided by 7 is negative 4. M's cancel, but n cubed divided by n is n squared. Now, this is still difference of two perfect squares. Remember, what multiplies by itself to get m to the 6? Well, just divide that by 2. It's even. It's definitely a perfect square. That's m cubed times m cubed. So sure enough, let's rewrite the 7m in, but this will factor into two more binomials. We just said m to the 3rd and m to the 3rd. What multiplies by itself to get 4n squared? Well, that's 2n and 2n. One's positive, one's negative. Now it's done. Think about this. Can I go further with this? I know m squared is a perfect square, but 2n is not. So it's done. That's our answer. Okay? All right. Hopefully you're understanding this. Let me check the time. Yeah, we're doing really good. So we're going to move on to sum and difference of cubes. Sum and difference of cubes. Because they're very, very, very much the same. I mean, it's just two little things that change from one to the other. And we're going to talk about that in just a second. It's pretty simple. It's something that you kind of have to memorize. But anyways, let me remind you of some perfect cubes. You've got 1 cubed. That's 1. You got 2 cubed, 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125. 6 cubed, 216. 7 cubed, 343. 8 cubed, 512. 9 cubed, 729. All the way up, and we'll stop at 10 cubed, which is 1,000. And that probably will cover us for most of them. But here's the deal. This is one of those times or problems where a binomial can be factored again. Now, listen, I told you that difference of squares is the one time a binomial factors into two binomials. And I stand behind that. This is the only time a binomial factors into two binomials. So what's the rule with sum and difference of cubes? Well, sum and difference of cubes is the one time a binomial will factor into a binomial times a trinomial. A binomial times a trinomial. And here's how it works. You first, for your binomial, you find the values that will multiply by itself 3 times to get a cubed. You find a. And then in the second part of that binomial, you find the number that will multiply by itself to get b cubed, b. And then in my trinomial, here's my 3 parts. You take this value and square it. And on the other end, you take this value and you square it. And in the middle, you take this value and you multiply it by that value, a times b. And then here's how it always works. If it's sum of cubes, if this sign is a plus sign, then your binomial has to follow suit. It has to be a plus sign. And if this is a plus sign, this middle sign, in order to offset this, has to be negative. And since this is b squared, it's always positive. Always, always. And that's it. That's the rule. I'm going to skip ahead a little bit. Go to the back side. And this is difference of cubes. Same rule. Look, same rule. They're both perfect cubes, but this time it's a minus sign. See, when it comes to cubes, both sum and difference of cubes factors the same way pretty much. It factors into a binomial times a trinomial. You still get a and b in your binomial. You still square a here. You still square b here. And you still multiply a times b here. But I bet you probably already know what the difference is. If this sign is a minus, then my binomial has to be a minus. And to offset that, this middle term has to be plus. And what do we say about b squared? It's always positive. And those are the two ways that you factor sum and difference of cubes. It's really simple. Okay, it's probably a little harder than difference of squares, but it's pretty much the same. Just a quick little easy rule to live by. So look at number 11. Is x cubed a perfect cube? Yes, x times x times x. Is 27? Yeah, it's on that list. It's 3 cubed. So therefore, this will factor into a binomial times a trinomial. So let's start with the binomial. X and 3. And then what goes in this first part? Well, it's your a value squared. What's x times x? X squared. On the other end, you've got b squared. That's 3 squared. 3 times 3, 9. And then what do we say you have right in the middle? A times b. What's x times 3? 3x. So I like to get that out of the way first and then do my signs right at the very end. Remember, if the original sign was plus, this has to be plus, and this has to offset as a minus. And that final term, always positive. Done. That's it. And let me say this. You remember back when we used to factor trinomials? you will never be able to factor the trinomials of sum and difference of cubes. This will never break down further, ever. So no need wasting your time trying. It will not do it, okay? So leave it be. All right, look at number 13. I'm going to do a couple more of these since you've never seen these before. So this is m cubed. Yeah, that's a perfect cube. Remember, if it's a multiple of 3, it's a perfect cube. If it's even, it's a perfect square. If it's a multiple of 3, it's a perfect cube. So m cubed definitely is. How about 216? Is that my list? Yep, there it is. It was 1, 2, 3, 4, 5, 6 square. It's 6 cubed. 6 cubed. And then, of course, n cubed is definitely a multiple of 3. So this is definitely the sum of cubes. So I'm going to turn it into a binomial times a trinomial. And just leave yourself plenty of room. Again, what multiplies by itself 3 times to get m cubed? M. What multiplies by itself 3 times to get 216 n cubed? That's 6n. Remember what we do in the trinomial? We square the first term, m times m. We square the second term. 6n times 6n is 36n squared. And then what do we say we do with those middle terms? To get that middle term, you multiply. What is m times 6n? That is 6, and then put your variables in order, mn. So there it is. That's all my factors. Easy as can be. Last thing, signs. If the original is plus, so is the binomial, and this offsets it as a minus. The last term is always positive because it's b squared. Has to be positive. So let's scroll across and look at number 14. I'll leave that up so you can see it if you didn't quite get it. 343 and 64 are both on my list up here. Look, that's 7 cubed. That's 4 cubed. Okay, be careful. Don't put 8. That's 8 squared. But these are perfect cubes. Look, that's cubed. That's a 3. So it's 4 cubed. So therefore, I'm going to factor this into a binomial times a trinomial. So let's start with the binomial. What multiplies 3 times to get 343 p cubed? Well, we already pointed out that's 7p. And what multiplies by itself 3 times to get 64 q cubed? We pointed that to be 4q. And then let's do our trinomial. Remember, in this first spot, we take 7p and we square it. Guys, that's 7p times 7p. That's 49p squared. On this end, we have 4q squared. That's 4q times 4q. That's 16q squared. And then remember in the middle term, we multiply these. What's 7 times 4? 28. And what's p times q? pq. So the middle term is 28pq. And then we finish this thing off. Plus sign here, minus sign offsets it. This is always positive. Done. Sum of cubes. Okay, let me do one more. I'll do number, I'm not going to do number 15 or 4 year completion. I just want to remind you, pull out a 4. That'll leave you with 125a cubed. That's a perfect cube. Plus 1. And 1 is definitely a perfect cube. Let me do number 16, and then we'll flip it over and do difference of cubes, which is identical. So it's not hard. Here, 24 and 375. You might have a hard time finding whether 24 and 375 both have a GCF of each other, and they do. Okay, I would start with 24 and just work through the factors of 24. Look and see if 24 goes into 375. It does not. Then try 12. It does not. Then try 8. It does not. Then try 3. There it is. 4 maybe. But 4 goes in there. 4 goes in there. No. Way wrong. 4 does not go into 375. But 3 does. Let's pull out a 3. 3 goes into both. Now look at your variables. This has 4c, c to the fourth. This has c to the first. So I can only pull out c. This has a d. This one has d to the fourth. We can only pull out a d. So we can pull out 3cd. Well, 24 divided by 3 is 8. C to the fourth divided by c is c cubed. And all of a sudden, look, the d's cancel, and 8c cubed is a perfect cube. How about 375 divided by 3? Well, that's 125. The c's cancel here. Look, c over c. And then d to the fourth divided by d is d cubed. And sure enough, that is a perfect cube as well. So here we go. Ready? It's the one time a binomial will factor into a binomial times a trinomial. What multiplies 3 times to get 8c cubed? 2c. How about 125d cubed? 5d. Then, of course, in our trinomial, we're going to square 2c. 2c times 2c, 4c squared. Then we're going to square 5d. 5d times 5d, 25d squared. And then in the middle, we're going to multiply this. 2c times 5d, 2 times 5 is 10. And then c times d, cd. Now, last thing, if that's a plus, so is my binomial. This has to offset it as a minus. This is always plus. This is sum of cubes. Now, if you go back to this, now we're in the same ballpark. We're just dealing with different signs. Okay, different signs. This is difference of cubes instead of sum of cubes. So for the first one, definitely difference of cubes. So it definitely will factor into a binomial times a trinomial. X, 1, right? We're going to square x. X times x, x squared. We're going to square 1. 1 times 1 is 1. We're going to multiply those. X times 1 is 1x. If this original is a minus, this binomial has to be a minus. And to offset that, that has to be a plus. What about the last term? Always plus, no matter what. No matter what. Okay? So let me do a couple more. Number 19. 2 16s on my list I showed you earlier. Remember that's 6 cubed. 125 is 2, so it definitely factors into a binomial times a trinomial. So that's 6k and 5. 6k and 5. We're going to square 6k. 6k times 6k, 36k squared. On the other end, we're going to square 5. 5 squared is 25. In the middle, we're going to multiply these. 6k times 5, 30k. So to finish this off, remember, if this is minus, this binomial has to be minus, and the middle term offsets it. The last term, always positive. And that's done. Okay? Now, with 21 and 22, I do want to remind you, don't forget to check to see if there is a GCF. Sorry, I was checking something. And sure enough, for number 21 there is. You can pull out a 4. And it leaves me with 1, which is a perfect cube or a square, minus 32 divided by 4 is 8. And that's h cubed, which is also a perfect cube. So we can pull out this binomial and make it a binomial times a trinomial. So here we go. What will multiply by itself 3 times to get 1? 1. What will multiply by itself 3 times to get 8h cubed? That's 2h. And then in our trinomial, we're going to square those values. 1 squared is 1. 2h times 2h is 4h squared. And then in the middle term, we multiply those. What's 1 times 2h? Well, that's just 2h. And then the last thing, if the original sign was minus, so is the binomial, and that middle term offsets it. The last term is always positive. Done. Okay? All right, I'm going to do one last one, number 22. Notice, you can definitely pull out a 2, and that leaves you with x cubed minus 27 y cubed. Both